With the opening remarks concluded, we now move to our first keynote session. We are honored to have with us Dr. Klaudia Dussa-Zieger, ISTQB President, who will share her insights on the topic ISTQB and AI. How do the two go together? Dr. Klaudia is a renowned expert in software quality and assurance, known for her pioneering work in the field. Please join me in welcoming Dr. Klaudia to the stage.
Salam alaikum, welcome to my presentation. I'm very honored to be here and having been asked to talk about AI or generative AI in software testing, and I hope I can give you some insights. Just to move. Sorry. No, I can just use the laptop if the clicker is not working. It's on. It's on.
It's on.
It's on. Sorry.
Yeah. Oh, right and left.
Yeah.
Right? Okay.
So let me just give you a little bit of background so that you know with whom you're talking. I am the current ISTQB President, and I'm very proud to actually do this job. And within ISTQB, I'm also the group lead for the AI testing syllabus. I'm also working at the national level, so like you have the Egyptian software testing board here, we have a German testing board. I'm within the ISTQB committee there, so I am the vice president there. In addition, I'm also working for standardizations. I'm the lead of the German standardizations group for software and systems engineering. And I'm a guest lecturer at the university, so I feel very happy that you have close connections to the university here. And I am the lead of consulting at Imbus. And the reason why I'm giving you this long list is that I have been a software tester for about 27 years now. I am not a data scientist, and I am not a neural network developer. So what I would like to share with you is actually my experience when we started to look into AI, and we did that, or I did that starting back in 2018 and 2019. So way before ChatGPT, right? AI was already a big topic way before ChatGPT. And the way how my brain works is that when I touch a new topic, when I want to learn about a new topic, I need to understand where does it come from. And looking at AI, I was not very surprised. I knew that it had been around for a long time, but I wasn't aware that we are talking about all the way back to 1915 to Alan Turing, who devised the Turing test in order to be able to see whether a machine is intelligent or not, just by looking at the answers, if it's not distinguishable whether it has been replied by a human being or by a machine. So back then, people started to look into AI, and from the very beginning, you can see these two different directions: research and symbolic AI and sub-symbolic AI. So symbolic AI explicitly modeling knowledge, expert systems with deduction rules, how you come up with new knowledge, and the sub-symbolic area actually looking how a human person is learning, so mimicking the brain. And what you see in the middle of the slide on top is the first mathematical model of a neuron, already published in 1958 by Frank Rosenblatt, so more than 60 years ago. And since then, of course, from one neuron, we moved to neural networks. We did some improvements in the deduction logic. We moved into the area of machine learning. And as you perhaps can see, you see these two nice little snowflakes on the bottom. AI was not a success story all along. We had AI winters or ice ages where the funding for AI was frozen because some of the governments thought it's not worth spending any money. So the tricky question, or the exciting question, is what happened that it is so important now? What happened? And I think the major breakthrough has two aspects. Most of the AI models we're talking about these days are talking about neural networks. And of course, we have advances in the statistical learning method. But why does it work so good now, given the fact that we have been talking about neural networks already 50 years ago? And I think there are, as I said, two aspects. Number one, the hardware is becoming cheaper and cheaper, and we can run lots and lots of calculations in order to foster and model the neurons. That is number one. And I think number two is even more important. We have data. We have the electronic data. If you go back 50 years, how much electronic data would be available? No internet yet, no social media, no smartphones, nothing. So the amount of electronic data that was available back then was not sufficient to actually train the systems. And this is where we are different now. So we have advances in the architecture of neural networks. We have the transformer architecture, which we know since 2017, but we also have cheap hardware. We also have sufficient amount of data in order to train it. And if you look into the media, at least the media in Germany, and I would also say in Europe, if they are talking in the newspaper about AI, they're basically talking about neural networks. And right now, they're talking about large language models such as ChatGPT. And what is the trick about ChatGPT? And I'll just use ChatGPT as a placeholder, because besides ChatGPT, of course, we have Gemini, we have open source models like Llama or Claude, we have the newest model coming from China, we have DeepSeek. So I'll just use that because it's the best known so far. Why did it explode in the general public? And the breaking date is November 2022, when it was published, ChatGPT 3.5. And again, I think there are several reasons that make it understandable what happened there. Number one, it was easy to access. You just needed an Explorer and internet connection and you could access ChatGPT 3.5. So it moved out of the niche of a specialist domain, which it has been all along. A lot of specialists and experts were working on AI, but now it was easy accessible. It was very cheap. For the public version, you didn't have to pay anything. You could just access it. And number three, the quality of the responses was pretty amazing. So the quality of what you would get back, independent, almost independent of what you ask it, was very, very high. And I think a lot of people were just amazed. And that is what kind of started this entire fever or hype all around AI and Gen AI that leads to the current involvement of AI and Gen AI in software engineering and also in software testing. And again, bear with me. I need to understand at least roughly how it works. So how does a large language model in general work? Well, as I said, you have a neural network. For the neural network, you need to train it. You need huge amounts of data. For ChatGPT 3.5, they were crawling the web, they were using Wikipedia, they were using online books, so PDF. Nowadays, you can also look at AI-generated content, so you have a lot of data you can work with, training data. And in addition, these networks were huge and they were trying to optimize lots and lots of parameters. And for I'll stick with ChatGPT given the fact that it's so good documented. For ChatGPT, we're talking about 175 billion parameters that you try to optimize in order to get a result. So training with huge amounts of data, optimizing a lot of values or parameters. And what it actually does, or what every large language model does, it predicts the next word. So if you give it a sentence or a little sequence of text, for example, like here, the quick brown, and then you are waiting for the next word, it will give you the next word. And the neural network, the LLM, will give you an estimate whether the next word could be cat, whether it could be dog, or whether it could be fox. It is not a probability. If you add it up, it's more than one, so it can't be a probability, but it's like a probability index. And in that sense, it would give you fox as the next value. How does a large language model do that? Well, what it does is that it actually breaks down a sequence of text into so-called tokens. And you can see it here for my example sentence. So a token can be a word, it can be a part of the word, it can be a letter, so it kind of depends. On average, a token, animation, on average a token is 0.75 words, and you will have different tokens for different large language models, for different LLMs, and you will also have different tokens for different, that's what I said, for different LLMs. And in addition, the context of an LLM, so what you give it as an input, is defined by the number of token. So what we need to do now, if we go one further down to further understand how it is working, is that we need to look how we get this text into a computer. So we need to translate the text, the sentence with the brown fox that jumps somewhere. It has to be converted into zeros and ones. There again are several techniques that can do it. What you see on the screen right now is the so-called technique bag of words, where you do a mapping between your input sentence and the tokens, and you mark it with the 1 when the word appears in the list of tokens. It is a very sparsely set matrix. Sometimes you will have 2 ones, most of the times you will have less, but it is a mathematical depiction of your sentence, and that will go in the next step in already pre-trained neural network. So this is where it goes into an LLM. It works through the network, and what you end up with is what is called an improved context matrix. And this matrix is not the probability or the probability index. This matrix actually, you have a set of vectors that represent the position of that word within the entire world that the LLM learned based on all the data that it got in. So if you imagine an LLM being trained on huge amounts of data, you have an n-dimensional space, and your sentence where you're trying to predict the next word is input into this huge space, and then it calculates you or gives you the position of that word in the text. So you have a vector, a mathematical vector. The idea being that words that are close to each other are closer together, like cat, dog, bird, and stuff like that, and other groups of words being further apart. And the trick now is that given the mathematical representation of a word, you can do calculations on words. In theory, you could say king minus male plus female equals queen. Yeah? You changed from the word representation into a mathematical representation, and this mathematical representation can now be used to work with the text. And this is what is happening now. You go through the loop several times, and then at the very end, when you did all the processing, you actually get this probability index with the different values for the next word. Please keep this in mind, this word embeddings, because we will be using them later on for some of the examples where we actually use Gen AI in software testing. This is like a very rough understanding, and I'm 100% sure that we can go into further detail on the technicalities, but for the time being in this keynote, that's enough. What are the advantages and disadvantages? Well, not to a big surprise, such LLMs have a very good understanding of language, and we're not talking about human language, we're also talking about technical languages. So no surprise, they're also good at programming, being a programming language. They are very versatile in use. If you just think back at ChatGPT 3.5, you can ask ChatGPT to support you writing a test specification. You can also ask it to plan your touristic sightseeing tour in Cairo. You can do that. You can also ask it to write a poem for your grandmother for the next birthday. Yeah, so wide usage. And once the model is trained, and please keep in mind that the training phase is a different one from the operational phase. Once such a model is trained, it is very fast. I'm pretty sure that all of you have played around with ChatGPT or Gemini or whatever model you choose, and you get the feedback instantly. So you don't wait for 3 minutes or 5 minutes or 10 minutes. You get it very fast. And given the fact that you have a model that can learn, these systems can also adapt. Now, on the downside, I think it is easy to understand that the quality of the model depends on the quality of the data. Depending what you tell the model or what you give it as input, you will get better or worse feedback out of it. That's unfortunately the case. You need to provide it some context so that it knows what you're talking about or where you want to go to. And sometimes we have this loss in the middle. If you provided too much context, it may forget some of the details. Let's say that you ask it to specify a test case with 3 equivalence classes. Perhaps it forgets that you wanted 3, and then you tell him, you gave me 4, I just wanted 3. And then he nicely says, yeah, sorry, I forgot, and then he does something else wrong. So it's not always really working properly, and one fact that everybody really needs to be aware of, it does hallucinate. Keep in mind, the model predicts the next word according to the probability distribution of the words that it learned, not depending on its truth value, right? So it's just the probability. So when using Gen AI, and that is actually the summary I want to give you for the theoretical part on AI, before I move to the testing, just be aware what you're dealing with. Be aware what it can do, what are the strengths, and be aware of its weaknesses. A model, despite the fact that it sounds very nice sometimes, a language model doesn't think. It gives you the next word, the next text according to some probability. It is a language model, and for example, not a calculator. And the reason why I put it here in such blunt words is because I know that if you ask a language model to do some calculation, it will in the background create some programming code that actually carries out the calculation, but that is not the intention of the language model. If you really want to do some fancy calculation, please use a calculator, use Excel or whatever, use R, whatever seems suitable for your needs, but don't use a language model. A language model is there to work with language and nothing else. But we do have a lot of applications that require working with language. So how can we use it with testing? How can we use generative AI to support us in testing? What you see on the screen is the test process according to ISTQB and also coming from ISO 29119 Part 2, which talks about the test process. So you start out with the planning, you schedule your testing tasks, then you do the analysis of your requirements, of your test bases. Then in the next step, you design the test cases, you come up with what you want to design. With the test data, you need to spend some thought about the test environments. In the next stage, implementation, you actually look at the scripting, you do test automation scripts. And after that, either manually or automatically, you're executing the tests. So you get test reports, you get defects, and hopefully you will do beautiful defect reports. And at the end, we're talking about some more management activities with writing test reports, writing summaries, and also giving defect reports. So if we stick with this generic test process, where can I use Gen AI to support me? And I would like to give you some ideas or show you some examples where we actually use Gen AI in our company. And these are the ones that are marked with a little green robot that is supposed to depict AI in our presentation. So the first one is that you could start out using AI in the analysis of requirements. And I just learned that there was an event last week on requirements and artificial intelligence. What we did there is that we actually looked through requirements. We are a testing company. We do get requirements, and every now and then we see duplicates. Every now and then we see inconsistencies. And we thought it would be a good idea just to analyze the requirements and see at least if they are similar, if we have duplicates. So we used the word embeddings that we saw before, and we calculate a similarity index. The similarity index is an input to the tester, and then the tester decides, yes, it's a duplicate or not. So this is the first spot where you can do it. The second spot where you could use Gen AI is actually in the generation of test specifications. And I will give you a long example after this slide. You can use it, of course, in generation of test data. So the green one is that we did ourselves. The blue little robots are examples that came from partners or from conferences. So generation of test cases, not test cases, of test data, especially in the insurance environment where you need big test sets of data that match certain criteria. You can give it the database scheme, and then the tools will develop the test data for you. So that works really nicely. Of course, you can use support of generative AI also in coding. Whether you are coding a test script or whether you're doing normal programming doesn't really matter. So you can ask it to help you. Whether you're using Copilot or other tools also doesn't matter. So support in coding definitely works. And when I'm talking about support in coding, I'm not only looking at the test automation scripts, I also look at infrastructure as a code. More and more, we need to set up virtual machine special environments. We're using tools like Vagrant or Ansible, where you have a piece of code that determines which operating system, which other tools you need to have. And this can also be done with the support of Gen AI. So not only the scripts, the automation scripts themselves, but also the scripts for setting up the environment. What else can you do? Test automation is the bread and butter business of our testing company, and we do a lot of keyword-driven testing. So we come up with keywords, and perhaps like most programmers, our testers like to type or develop the automation scripts, but they don't like to document them. So within our management tool, we inserted a button, document the tests, the keywords, you press it, and then you get a beautiful documentation which wraps up the parameters, which says what is the general intent of that keyword. So we can document it nicely just by pushing one button, and we can also review it. For keywords, we have a set of rules. For example, if you test automated, we don't allow that you say click on the button or push the button or just use the button. It has to be a particular word, so we have a glossary. It has to be an imperative, not just the basic version of a verb. So we have a set of rules, and we can use, or we did use, a generic AI. In that particular case, we didn't use ChatGPT, but we used Open01 because we needed a reasoning model, and we did a review. So the generative AI reviewed what we had implemented and told us, yes, you followed it nicely, or most of the cases, you didn't use the proper term, you didn't use the proper format that you were supposed to do, and then you can change it, and then it would review it again. So this was actually something that helped quite a lot, especially given the fact that we have a distributed automation teams that work in different countries, where sometimes the understanding how programming is supposed to do is not quite the same. So that helped to get rid of a lot of basic errors just to improve the quality of the keywords and then later on of the test automation scripts. So that works also very nicely. Self-healing test scripts. This is also a domain where you can use Gen AI Some of you may already know Smart Bear or Eggplant, where they use self-healing test scripts on the graphical user interface level, where they recognize whether one test object just moved slightly. Here, I'm really talking about a self-healing test script based on a language model. And what they do there is that, again, they're using this word embeddings. And if you're trying to use an identifier in XPath and it doesn't work, then the model in the background searches for one that is closely related in the large language model, and then it uses the next one. And if that works, it's fine. If it doesn't work, then it generates the next one. So you can actually use word embeddings in large language models to help you with self-healing test scripts. One thing that I like quite a lot is another application that we did, which I coined here as explanation of technical defects. As I just said, we are doing a lot of test automation with keywords. So we have the domain-specific keywords, and then we have the technical keywords. And sometimes you get error messages back that are on such technical level that it is very hard for a domain expert to understand what went wrong. So we implemented an AI model, a small language model, that would translate the technical defect in a domain-specific way so that the domain users could actually understand the defect. And they were quite pleased that they're more able to interact with the testers, with the automation testers, in order to advance the quality of the product. So that worked also really well. Test case selection. You can also use a large language model to do that. Test case selection in a particular sense, not to test the changes, but if you want to have the maximum coverage of the code with as few test cases as possible, again, you can use a language model. You use the word embeddings. You start out with one, and keep in mind that similar test cases would end up in a similar region of your language model. You use the one that is the furthest away. So instead of going through all the test cases that perhaps are connected with a login procedure, you would take one, and then you would move completely out and do some navigation in the window tree, or you would do some calculation. And with that application, which is actually developed by a small software company out of Munich, what they do is they derive the minimum number of test cases to achieve as much code coverage as possible. Quite interesting, especially if you need to show code coverage in a highly regulated environment, perhaps 80 or 90% code coverage. And one of the last things that we are trying to do is actually the derivation of a keyword library based on test specifications that exist for manual execution. This is still work in progress, and that's the reason why it is this dotted line. But what we would like to feed into the large language model is actually the set of test specifications that we have. And then hopefully, by giving it several steps, we can get it to the fact that it automatically derives keywords from these specifications, and that and the next step does the automation with some help of human beings. And as I said, I promised you to give you an example in more detail. So this is an effort, a project that we did with Fresenius Medical Care starting last summer. Fresenius is a company in the medical device domain, and they were planning to develop the next generation of medical devices. They had one particular product in mind. Given the fact that they are in the medical device domain, they need to show their work to the FDA if they want to get an approval for the American market. So they are keeping KPIs for all of their development activities. And they knew for a product, they have roughly 4,000 to 5,000 test cases. And they knew, based on their historical data, that for one test case, starting with the blank piece of paper, all the way to the release of the test case. So blank piece of paper, writing the test specification, reviewing it, approve it, correcting the stuff that you found, up to the point where you approve it. And I'm not talking about test automation, I'm just talking about test specification. They knew it took them 5 days on average. And the management said, if by the use of Gen AI, we could shrink the time by 1 day, and for the calculation's sake, let's just stick with that they need 5,000 test cases. So per test case, we save 1 day. We save 5,000 person days, which are several person years. And in that setup, the management was more than willing to spend money on a proof of concept to develop an AI component that would support them writing test specifications. They had several requirements. They said it cannot be ChatGPT, it cannot go into an open cloud. So the discussion was either to have some hardware on premise or to use a private cloud. We ended up with a private cloud. And we said we are going to use an open source model, and we started out with Llama 3.1 coming from Meta AI, and at the end we used Claude 3.5 Sonnet. And keep in mind, they knew that they needed to show to the FDA that they did a review of the test case. So it was never the intention to have a perfect solution. They just wanted to overcome the empty blank page. They wanted to have the AI produce something sensible so that the tester could continue from there and just get the stuff done faster. What did we do? We used the open model, so we started with Llama 3, and we used a RAG approach. RAG stands for Retrieval Augmented Generation. What you do there is, starting from the requirement, you feed some project-relevant documents into the system. In that case, we were using technical specifications for that particular project. We were using user manuals for that particular project. These informations were split up into text chunks. The text chunks, together with the requirement, were fed into a prompt. The prompt was fed into the LLM, and at the end you get an answer. So you get the first draft for the test case. That is the very generic level. Now, if you go one step further in the explanation, it becomes way more interesting. So let me take you to the next level. If we're just looking on the path from the requirement all the way to getting the text chunks out, the text sections out. So what we did is actually not only use one LLM, but we used a succession of different steps to get the information that we wanted. So we started with the requirement, we fed it into the first LLM, and what the first LLM did was to sum it up, so you got a management summary, if you want, of the requirement. Out of that condensed content, the second LLM would extract 3 key criteria or 3 keywords that you would be searching for. And this is something that we learned and which we implemented in one of the later versions of the prototype. This was the first step where we allowed human intervention. So after these 2 steps with the LLMs, you had these 3 keywords that were the search basis for our RAG database, and the tester could use his expertise and say, yes, these 3 look reasonable, or no, 2 of them look reasonable and 1 of them we will change. So somebody did a human intelligence check, said okay, and then in the next step we used HIDE, which is the hypothetical document embedding, that improved the text again and then did a search against the RAG database where we fed it project-specific information. And once we done with that, so that was the 4th step, we actually got our chunks, our text sections that we wanted to use. And keep in mind that the number of documents we can feed in there are multiple. So we're not talking about 1 document, but in that case, actually, we fed in 3 4 different documents. So now we have the text section, and now how do we get to the answer? When you have the text sections, what you can do is you get this probability index. Then you have different options. You can say you take the top 3, or you say you take the top result coming from every document that you feed in. So you can do some re-ranking dependent of what you want to achieve. That was step number 1. Step number 2 was actually the post-processing. And for me, that was particularly important because that post-processing would give you a tiny bit of traceability, because next to the text section, it would give you the source where it got it from. So you can prove, or at least you get an idea where that chunk of information came from. So once we did the re-ranking, once we did the post-processing with the traceability information, again, we fed it into a large language model, into an LLM, and then we had different options. And let me just click one thing, because the text chunks that he extracted, again, can be manipulated or can be improved by a human tester, feeding in his expertise. So that's what happened there. And then we said the testers wanted to have in the second version of that prototype, they wanted to not only get test specifications, but they also wanted to have equivalence classes and boundary values. So that is what you see on the right-hand side. And again, the human tester was allowed to check whether the classes made sense to him, whether the boundary values made sense to him. And if he said yes, then the system would go on and extract the actual test parameters, not using an AI, using a simple algorithm. These test parameters, together with the classes that have been derived and the boundary values that have been derived earlier, then again went into a large language model and generated the test case. So far, this is a prototype, a proof of concept. It was implemented as a web application using Angular and using Postgres in the back as database. And we did the presentation to the project group already several times, the ones that actually gave us the documents. And now a second project came forward and wants to have it. I'll give it another half year and then hope that we get in close integration into their requirements management tool, so that we don't have to feed in the PDFs and break them down into chunks, so that we have a closer integration with their requirements analysis. This was a very, very interesting experiment, and from my point of view, it went pretty well. Now, if you are a tester, do you think that you really need that testing with AI? And if you ask me, yes, we do. We definitely do, because the number of systems that have software in them is growing. Just go 20 years back and think of all the stuff that has software in it now. My refrigerator almost talks to the supermarket and orders some tools that did some food, and that didn't happen 20 years back. My smartwatch has a lot of functionality which it didn't have 30 years back. So the number of systems is growing with software. The connectivity is growing. They're more and more talking to each other. The number of devices upon which you want to run it, it's not only a laptop. We are talking about tablets. We're talking about smartphones. We need to look at different operating systems. We have to have responsive design. So this is all growing. And the demand for security, the demand for performance. Of course, if I'm using my smartwatch together with a bank application, I want the stuff to be secure. And I want it to be fast. I don't want to wait for several minutes. So security, performance, digital accessibility, that everybody can use it. These are all things that make our work not harder, but there is so much to do. And I think we should be more than happy if we have some tool, some technique that supports us. So I think we can use all the support from generative AI there is. And actually, I forgot the the left-hand side. The left-hand side is a graphic coming from SmartBear, which shows the amount of testing that is necessary in comparison to development speed. I mean, we're not talking about software that is being released once a quarter. We're talking about software cycles that go way down. If you think of Amazon or other e-commerce applications, they have several releases every minute. So yeah, more work, more complex tasks, more devices. We need help, or we can use any help that we get. So I think we need to embrace AI and use it to improve our efficiency. Now I take my second hat as the president of ISTQB. Now, how does ISTQB deal with AI? I don't know if you have looked at the ISTQB website. We have a new portfolio picture for about 4 or 5 months now. You see the foundation level in the middle, and you see the advanced syllabi like test manager or test automation engineer on the top. On the bottom, you see all the specialists. On the left-hand side, you can see other certification schemes with whom we formed an alliance. So these are partners for us. We have an alliance with IREP, we have it with IQBBA, which is the business analyst group, or with TMMI. On the right-hand side, we put supporting skills like project management or soft skills or communication skills with whom we don't have an alliance yet. We try to be up to date as much as possible. All the syllabi that you see on this portfolio picture are being evaluated the latest every 5 years. So we try to validate whether they're still up to date or whether we need to improve them. And we definitely also try to look into new topics like DevOps or AI. Now, if we look at this picture in particular, you can see that we do have an AI testing syllabus, one that was developed actually from 3 sources. And you can see them listed here and it was released in 2021 because AI was already a big hype there. A couple of people in the, I would call it ISTQB ecosphere, have been working on syllabi, and we merged them and came up with a syllabus which I consider is really very nice. As you can imagine, in 2021, large language models were not a topic yet. Generative AI was not a topic yet. So we are currently reworking the AI syllabus to be more up to date and be more focused on what is currently in discussion. You have the link there, and what you will find if you go there is actually the structure of the syllabus. All the information is publicly available. What you can see on top are the chapters in red and then the sub-chapters in blue behind. So the AI testing syllabus really gives you a very nice introduction to AI, what neural networks are, how machine learnings work, what the quality characteristics for such a system are, and how you can test them. So we're looking at metamorphic testing, we're looking at A/B testing, we're looking at back-to-back testing. So this is all information that you will see in this syllabus. On the very right-hand side, you see one chapter on using AI in testing. And about a year ago, we felt this is not enough with all the work going on in Gen AI. And that is the reason why we are currently developing a syllabus on testing of generative AI or software testing with generative AI. The syllabus is in beta review right now. The beta review will end on Thursday, and then we need a release motion, and hopefully this syllabus will be released pretty soon. It is talking about what is Gen AI, what is prompt engineering, what are hallucinations, what are the implications for energy consumption, how can you deal with LM-powered test infrastructure, and so on and so on. And this is also a syllabus where we focus strongly on hands-on experience. So it will be a requirement you actually do lots of exercises with different large language models so that you can see the differences, how they act. So this is from the point of view of developing syllabi for AI or for Gen AI. On the other side, we have also been using Gen AI when we develop syllabi. The first group actually started to use ChatGPT to improve the text, and this is particularly used when the authors or the editors are not native English speaker. So if you have somebody from Germany or if you have somebody from Sweden, they might not use the best English, so what they tried is to actually use an AI to support them. That worked, but again, we have this human step in between that says, yes, this sentence is better, or no, it's even worse. And the second thing that I would like to present to you is actually the practical user. This is a portfolio picture you see has changed on the left-hand side. It is not yet on the website. It was presented at the General Assembly in Dubai 3 weeks ago, and Dr. Hamza might know it because he was there. This is a partnership that we did with A4Q, and they developed what they call a practical tester. It's officially an ISTQB add-on because they are using learning objectives coming from the foundation level and from the test manager. And what they did, and this is actually the third bullet point down there, they developed and they trained an AI, a large language model, to generate as many test is the wrong word, to generate as many exercises as possible so that you can practice. This syllabus is actually focused on building up your practical skills, and they are again using generative AI. So from ISTQB perspective, we have syllabi that deal with AI and hopefully soon that deal with Gen AI, but we are also using it to become more efficient during the development, and especially with this add-on module also to support us and to support our employees to become more efficient in the skills. And this kind of leads me to a summary. From a point of view of testing with AI, what we believe is that for the entire testing process, there will be specialized little AI components that support us. The one that we used for Fresenius with the test specification is one example. Then the one, for example, with the documentation or review of keywords is another example, or the translation of the error messages. I think we will have specialized modules with the need of having the human brain, the human intelligence sitting in between and evaluating whether the results that the AI produces are really good or not. So testing with AI is not going to disappear. AI has been around for such a long time, and with the advent of ChatGPT, with the really usable models now, we need to be aware of the technology and we need to use it to support testing. It can make our life easier. We can become more efficient. So the goal is really to work on your know-how and skills. Some people say that if you don't start to use it now, you may lose your market share in 5 years or in 10 years, and I think there is truth to that. If other companies are 20 or 30% faster than you are, at the end you will lose. So this is testing with AI. So far I haven't talked about testing of AI, but the number of systems that actually do have an AI component in them is also increasing. And with the EU AI Act, where we have to follow certain requirements, and I know that there are also some regulatory efforts going on in other parts of the world and also in Egypt, these AI-based systems, that have an AI component in them also need to be tested. If I have an AI component in the finance sector that decides whether I get a loan or not, I want to know, or I want to make sure that it is working properly. So also for this part, We need to work on our skills and be able to test such systems. And perhaps to sum it up, because some people are afraid that they might lose their job due to AI or Gen AI. I don't think so, not at all. The skill profile will change. Yeah, you need to have different skills, but there is so much work to be done in order that we trust these systems, that they are transparent, that you can understand why they're doing it. We won't run out of work. For me, having been around for a while now, it is a little bit similar to the situation we had 20, 25 years ago when test automation came up first. When test automation came up, all the manual testers thought, we're running out of work. No, we have more testers now than we had back then. We will always have manual testers, but the skill profile changed. Now you also need to know how you can do test automation. And test automation is work. You need to set up the framework, you need to do the test scripts, you need to do the execution, you need to do the maintenance. So I'm not concerned at all. There is plenty enough work, but we need to work on our skills. We need to be open-minded, open to technology. Don't be shy, be brave, go for it. And then I think we have lots of interesting work ahead of us. Thank you very much.